Okay, so we're writing the equation of lines, and we want to tie that into our knowledge about the slope of parallel and perpendicular lines. So we're going to pick up right here with write the equation of the line passing through the points, and we're given -2, 6 and 4, -6. So we're going to pick up right there with the things that we already know. Remember the model equation that we're using. Sorry about that. That is a constant issue. The model equation that we're using is y equals mx plus b. And our goal is to fill in m and b. So the first thing we're going to do here is figure out m. So we need the slope. So slope -6 minus 6. We have 4 minus -2. So it looks like our slope here is -12/6 or -2. So that's the slope of the line. We use an x and a y. It does not matter which is which. You can use 0.1 or 0.2. That doesn't matter. And we plug it in to figure out b. Right? So we're doing the things that we've been doing. Our y is 6. Our slope we just found out is -2. X is given to us as -2. And we're going to find b. So 6 equals 4 plus b, and b equals 2. So finally, we're just going to take our m and our b, and we're going to write the equation filling them in. Y equals m was -2, x, and then our slope, our y-intercept rather, b was +2. And we have the equation of the line. Well, now we want to tie that into our knowledge about parallel and perpendicular lines. So look at the next part here, part B. We're going to write the equation of a line parallel to that one. So we still need slope. They're not giving us slope, and they're not even giving us the points to find slope. But they're telling us how our new line compares to that one. Well, the slope in part A was -2. We want parallel, which really means same slope. So we're going to use a slope of -2. So we've already got our slope. From there, we're going to do the same things. It passes through the point 8, 4. So we're going to plug that in. There's our x and our y. So y equals m x plus b. 4 equals -16 plus b, and b equals 20. And finally, we're going to write the equation. Y equals mx b. And we have the equation of a line that is parallel, but happens to go through a different point or set of points. And finally, in our third part here, we're going to write the equation of a line perpendicular to that line. Well, perpendicular means opposite reciprocal. So perpendicular for us, that means we're going to use the opposite reciprocal slope. Reciprocal slope. So if the slope was negative 2, our slope is going to be positive 1/2. We want opposite reciprocal to that other line. So its slope was negative 2. We want to be perpendicular, so we're going to use positive 1/2. And it passes through the origin. Now the origin is 0, 0. So they're giving us our x and our y. So we're going to plug it in. We do exactly the same thing. You don't have to do anything different. Our intercept here is 0. Now, we could recognize that because it's the origin, so they're already giving us the intercept, or we can plug it in. That doesn't really matter. That saves you time. But either way, we're going to get the same result. Our b is 0. And again, we know that. And we're going to write the equation. Y equals 1/2 x plus b. But we would never show plus 0, right? Plus 0. But we're not going to do that. We're not going to leave it as a plus 0. But whatever the number is, that's what we have. So we can use our knowledge about parallel lines having the same slope, perpendicular lines having opposite reciprocal slopes, and we can write the equation of a line. Well, we're tying that together now. We're saying write the equation of a line parallel to that line or perpendicular to that line. So the original line, or whatever line we're referring to, it's a reference line because the next line refers back to it, parallel to it, perpendicular to it. So we're referring to an old line to figure out our new slope. Other than that, we're just writing the equation of a line. The way we're getting the slope is by using some new knowledge. Perfect.